Microphone. Bop. There we go. Lower the decibels a little bit. Should be good. There we go. Yep, it's up. We're good. We're good. All right. So, this is just a test stream. But we are going to be working on our robot arm, our robotic arm, using Fusion360. So, to start off with, or at least where I left off in my last recording that hasn't been made public yet, we're working on a video essentially to put that all together. But we were working on like the foundation of the robot arm, and I had to do some brainstorming on this. Let's see if I can move this over here. Had to do some brainstorming on this, especially because with at least the base with what we have, I just needed to figure out where we wanted to put a servo, so that way it can rotate on an x-axis, or at least its first axis. And then I had to think about pretty much how the robot arm is gonna be powered and what we're gonna use to power it, essentially. So I realized that in the design that I'm working on right now, there is just not gonna be enough space when it comes to there's not enough space in the base of the robot arm to put an Arduino or anything of the sorts, because the micro servo is going to be fit in here. So came up with a couple of ideas, at least on how the design would look. Let me just sketch something out real quick. Okay, that's ugly. Do I have anything circular but small? Let's see. This works. Alright. So start off here. So then we're thinking about controller. So this is where the microcontroller is going to be. Base of robotic arm. All right. So there is a couple of things that we can do with this. Okay, so if we have it like that, let's look at the top. Choose this face. We'll try to get it right there. Let's take out the Arduino we're gonna use so we can measure it. Oh, wait, it's right there. Alright, so this is an Elegoo 2560 Arduino Mega. This is what we're gonna be using, at least for starters, to test out the robot arm and to make sure everything is working properly before we kind of design our own PCB and then get that installed into a later version. But what we need to make sure is that the Arduino can fit snug, so at its longest length. Let's see. So it's about 101.3 millimeters. So from here to about there. So 101.3, or millimeters to inches. One oh one point three. So we're looking at 3.988 inches. So all right. So if about there is 100, and this needs to be 101. So if you add another 100, well, let's also look at the width of it too, because we probably don't need a crazy amount of length. If we put it at a smaller point of the circle or of our base, then we can measure it a little bit better, just get a little bit of a better fit. We won't have to use that much 3D printing filament. $53.3. Divide the length value by 25.4. So if we're going to find this in inches, 53.3 divided by 25.4, it's 2.098 inches. 2.098 inches. Okay. So let me actually do this first. Let's see if we can get... What the fuck? So 53. So that is literally gonna fit it. Okay, so I think we can actually make this a little bit smaller. So if we need about 101, let's give it 150. Actually, I wonder if we can... So width-wise, 53, let's give it about... Let's give it about 100, because I do want to be able to fit a little bit more into the area where the electronics are going to be, so about 100, and then we want it about 101.3, so let's do 150. Alright, let's extrude it first. I kind of hope that doesn't ruin. Let's see if we can make these go away real quick. Because then we can extrude it and then make it a little bit better. Now, the height of the base is around 2 inches, and an Arduino, or at least this Elegoo, is about let's go from its highest point. There's about 13 millimeters. So, I mean, I could make it the entire height, which is 2 foot, about 6 inches high. Which, I mean, it wouldn't be terrible. But then again, I don't want it to look too bulky. I do want it to look pretty modern, I would say. Or just smooth, you know. Let me see if I can actually put on some background musica. I was watching Iron Man, but I'd rather background on copyrighted music for, well, what would I say this is for? For creation. Copyright free music for Copyright free music for workflow for concentration. Let's see. Watch, we're about to get some some crazy shit. I want lo-fi. Let's see. All right, we're just gonna pick one. I seen something that caught my eye. Actually, no, I didn't. It's 2 minutes long. God damn it. Alright, whatever. We're just gonna find copyright free streaming music for YouTube. Why is it so hard to find copyright-free music? This is annoying. I think I'm just being too picky. Alright, whatever. I'm just gonna choose this. Ads block. See ya. Let me know how that sounds, guys. Let's see if we can change these lights as well. White light? Does that look good? I think it looks good. No? Alright, whatever. Alright, so we're going to extrude this. So let's do 4 inches in height. So that is 50.8. We want 101.6. Sure that's right. 101.6 is about 4 inches. Yep. All right, cool. So this is the front. Let's start by making all this clear or seeable. Let's take this, move it out the way. We'll rotate it about 90 degrees. Move this over. This is kind of how I want it now. Now I just got to figure out how I can cut it. But if we look at it from the side, wait, let's. Set up there. Let me know if the music's too loud, guys. I'll lower it. Or if you guys can't hear me or anything, make sure it's lowered. Alright, but if we look at it from the side, I think that is good. One thing I would say, I don't know, I kind of feel like I want it to be around the same diameter or just width of the base. just so that way it gives it a little bit more stability. Because if the robot arm's is going to be moving and stuff, it's going to be picking stuff up, and then it's going to add that weight essentially to that area of where it's picking it up, and then it can bend over and stuff, and or tip over. I kind of don't want that. Or should I make it a little bit more wider? Should probably make it a little taller, yeah. So if we do 1/2 inch, 0.5. Let me see, extrude. I mean, that kind of actually looks good. I think a little bit taller is good. That actually cut it out. Oh shit, now it's like attached to it. That's not good. Wrong face. Nope. There we go. Alright, so with it being a little bit taller, that looks good. Let's see. I feel like I forgot how to... I gotta figure out how to... what am I looking for here? How to cut a shape to fit with a circle in Fusion 360. Create a sketch on the face of your object where you want the cut. Draw your desired shape within the circle's boundaries, then extrude cut feature. Oh, I think I know how. Hold on. Let's go right side. Let's actually take, let's finish sketch. Let's take our shape here. No, what are you doing? Let's let's take our face here. No. No. And let's cut it back down. Right. And then let's, I think if I move it under it and then extrude, it should work properly. Yeah, now that just cuts out that part. Right, let's go back to this. Just lower it ever so slightly. Oh wait, what the fuck? Is that how we want it? I don't know why I'm turning my head when I can literally rotate this. Now if I take this, extrude, nope. There we go. Creates a body at the intersection of an existing body and the new body. Or, okay. Okay, here, I think I know what to do now. Let's take, what is this, body 1? Okay, let's make all of those invisible. Except for body 12.
Get the mattress of your dreams.
Oh, come on, ads. Body 12, rename it. This is going to be micro. This is where we're going to house our microcontroller. And then if we go to the bottom, okay, let's see what we can do here now. I'm pretty sure if I raise it, yeah, it is, okay. So we want this. Okay, I think I can make these seen now. Yeah, so if I do extrude it this way, it is gonna work. Okay. So first things first, let's, no, what the let's take this here. Let's line it up. As much as we can. Okay, that should be pretty aligned. If we look at it from a top angle, get a side profile. Okay. So now when we extrude this, nope, it's gonna extrude that. Take this face, extrude, get a side view. Now it should cut out. But then again, we have these slots here. Okay, let me try this. So if the total height is going to be about 6 inches, let's create a cylinder. Uh, 203.2 in diameter. Let's make our body invisible. Oh my god. And then now what we can do is we can push this into it. It is going to be the exact same diameter of our base, so whatever it cuts anyways is going to fit. And then if we take that, enter, get a side profile view, and then we extrude this up to 8 inches. That's 203.2. We already had that. Wait, did this select the... I think this selected the wrong one. Yeah, we're supposed to take that face. 203.2. Still selected the wrong face. How do I get my... There we go. 203.2. Then we want it about... Oh, what am I doing? So we want it about here, I believe. Yeah, so that's the second one. So this is our point that we want it to be at. So let's take that. Nope. That line right there. Now this should cut it out, I believe so. If I'm right, this should. Could be wrong. No, I think that's trying to cut it out. Or do we take... Yeah, okay. Wait. So that's 130 millimeters. Take this. Right? There we go. Now I think I know what I'm doing. I think. Take it to 130. Right? Then we take our body, our cylinder. If I can get this right. Let me move it up a bit so that way it's out of that. Let me take this face, extrude, rotate it, drop it, drop it. God damn it. Take this face. Extrude. Negative 200. Either way, if we position it lower, what am I doing? If we position it lower and then extrude upwards, it should cut it. So and if we get a top view, and then we want it to be, want this to be about there, right? How does that look from the side? Okay, this should work better. Oh, music's back. There we go. Take our face, extrude. Oh my god. Okay, I think that did it, yeah. Okay, so let's get that out of the way. Body, 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 body. And then now we can get a different top-down angle. Take that. And that fits perfectly. Let's rotate our view. Yeah, and then that fits perfectly. So now the housing is we could just remove this at this point. Delete that. Wait, what? Okay, that should be good. Should be good. Cool. Alright, now what we can do is we can hollow it out, get our dimensions set for the Arduino. I want to put some supports in there as well, and then we also have to hollow out the powering ports that they have here too. Now this model is going to run off of this one, obviously. Maybe the next few ones. I do have an Arduino Nano ESP32 that I can use, which might be a little bit better. I just got to figure out how many what do you call it? How many servos I can use with one of these, because I believe with the 2560 Mega I can use a lot, but with this one it might not be that easy. All right, we'll see. I'm gonna take a quick bathroom break and get some more coffee, and then I'll be right back. So stay tuned. All right, we back. Let me see. So I guess it's not a test stream anymore, right? Let me edit the. With Fusion 360. Description. Hold on, guys. I gotta make a description for this. Follow on my socials. Twitch at Jeremy OTR, right? OTR, and then Twitter, Twitch, TikTok. I think that's about it. Okay. Okay, hold on. I want to do a little bit of adjusting to my live overlay. I feel like my camera's a little too bright. Let me know how that looks, guys. And I wonder. Give me 1 second, guys. I'm trying to figure out if I can
This is big.
set up.
Enormous.
Let me do a little bit of a promo, or at least posting up my stream. Live on YouTube. Where is the red circle? Red circle. There we go. Add a link. Where the freak is the link? Oh. Paste. Custom sticker tag. Text. Boom. Okay. Give me 1 second, guys. Okay, I'm trying to see if I can get if I can stream live on TikTok and then just set up a tripod like right here or something. Because my computer right now, I feel like it's just not strong enough to do a multi-stream on multiple platforms. But give me 1 second, bear with me here. We'll get back to the design. Just want to make sure I can get everything posted. How are you guys doing today? Everyone in the stream. Let's get this music back up. X.com. YouTube. Designing. Probably should have had this going before I started the stream, but oh well. You live and you learn. See if I can get the link to my stream. Share. Copy. Cool. Alright, so that's up. Got that on. How's everyone doing? Let me show you guys a little side view while we wait, or while I try to get some stuff going. But for those of you who just are joining the stream, we are working on a robotic arm that I'm going to try and 3D print, put together, and kind of use it in different ways. I have a couple of ideas on how I want to use it, especially with working with a 3D printer. I want to be able to have this robotic arm take off the 3D prints that I have printed, so that way I can have either an AI assistant that I'm developing, or anything else, or whatever AI assistant I end up getting working, start up a new print, and essentially it can be kind of like a an automated assembly. You know, you can have the robotic arm take off the print, scrape the bed, and then start up the new print, and then kind of just like keep going in a circle, essentially. But that's kind of like the goal right now, or the plan. It is a very new sort of project that I'm kind of working on, or at least a new field of what I'm getting into, especially even with designing my own 3D printed, or just designing my stuff in general. Not very skilled, I would say, in that aspect, but as I do go on and create more things, I'm actually getting a lot better with this. But that's the goal, that's the plan. So this is going to be a very, very, very long project. I will be posting a YouTube video on this as well, so if you guys are not subscribed, make sure you do subscribe, so that way you don't miss that when I do end up posting it. Also, go check out my last video, which is me 3D printing a rocket that I designed myself. Show you guys here. Let's full screen this. So I designed this 3D printed rocket. It is not flight ready, I would say. There are a lot of things that I want to add before I even begin thinking of sending this in the air. But this is just a general prototype, or just a basic prototype that I designed just to see how it would come out. There are quite a few things that I want to improve on this, especially like the length of the rocket. This is more like a missile. And then, yeah, I have a couple of ideas on what I can do to improve this, or at least what I can do to enhance it. And we'll end up working on those in later streams, or at least working on those in future videos. But for now, this is just like a starting point. So that's what I've been working on, kind of. A couple of other things I've been working on that I still have yet to start the design process. We're still in like a brainstorming phase, but that's that. All right, let's see what we can do here. But anyways, how's everyone? Everyone's day? Skip. Done. It is a snow day today, so that's nice. Get to stay cozied up in the house and do some work. Let's see. Oh, shit. Alright, I don't know if I can go live yet on TikTok. I feel like I was able to, but live, download link. Here, let me see real quick, because I actually do want to be able to go live and get this out there a little bit. Open the app, swipe left until you see the live option, which I do see here. But then it's telling me to download something. Let me see if I can get it on the Google Play Store. It's gonna be a bit of a process. See if my iPhone will let me do it. Let's see. Settings. Damn it, man. I don't know if I'm going to be able to do that on this phone. Oh well. Let's see if we can download it on the App Store. Maybe that'll work. And then we'll just set it up to charge and stream that way. Yeah, maybe I'm just not eligible to do so just yet. I mean, I only do have like 50 followers, but still. Alright, whatever. Oh well. That's that. So we'll just leave it at that. Alright, so back to this. So if we get a top-down view. I don't know why, I feel like I want it to be a little bit bulkier. But then I'd have to recut it again. Alright, let's see. So if we're going with the if we're gonna use the Elegoo microcontroller, we need a spacing of 101.3 millimeters, or about 4 inches. So let's say we're gonna start. So we can do 120, but I don't like the fact that that wall on the end there. Oh, let me bring it back. Sorry. All right, cool. There we go. I forgot I was on my full screen. Okay, so we need a spacing of 101.3 millimeters by 53.3. So I think 115 will work. And then 53.3 is like within that range there, so we can actually extend it just a bit. Have it about 80 millimeters. 115. Boom. Now what we can do is we can extrude. And then now we should have that spacing. I almost kind of want to print this out just so that way we can see exactly how it's going to look. Yeah, I think that'll look fine. Do you guys feel like it's too tall? I don't know. Alright, let me see if I can bring that over to my 3D printing software, and then we can test print this just to make sure that the Elegoo fits in properly, and then we can kind of go about different ways on how we can improve it. We're gonna need some holes here so that way we can put in the ports. And then we're gonna need to figure out what we can do as far as wiring, because that's gonna be another issue. But I think that's gonna have to come when we get the rest of the arm designed. Let's see. So let's take that away. Let's save. Oh, I need to export this. Oh damn, that's freaking huge. Yeesh. That's gonna take a while to print. What I can do, scale it face wise. Scale it down just a bit, just to make sure it fits that way. Fast. Gray. And slice. So an hour and 28 minutes, jeez. I mean, I can make it smaller. Not smaller, but scale it down again. Just enough to where the microcontroller can fit. That should be good. Now that should actually fit fine though. Bruh. Nope. So this is gonna be 80, and that's 53. Okay, I think we need to make a... let's create a sketch. Rectangle. So 101.3 and 53.3. So we'll do 101, 102. That would work. And then if that's 53.3, we could do 54.4. Okay, so now that we have that, let me actually extrude this face up a little bit, and then we can create a spacing for it. That's almost perfect. So that's the tail end. And then that's where we'll have the electronics come out. I could flip it around, it'll be the same size, but then the electronics will be pointing out this way. But that'll just allow us to still see if it fits in general. And then we can create the spacings and holes for the power slots. Okay. Let's save. Micro housing. Now we can take this. New project. Discard. Import. Scale. Oh, I think I see an issue here. That should be a lot better. Alright, let's see if see if this looks better. How long have we been going? 2 hours almost. Okay, that looks a lot better. So let's scale that down. See how long it takes to print. Oh, but it scales that down as well. Shoot. Unless... Alright, this will just be a test. And then we'll Control C. I mean, that looks a little bit better. No? I mean, that'll work just fine, actually. Something like that. Okay. Let's see how long it'll take. 1 hour and 32 minutes. Alright, fuck it. That's worth it, I guess. In the meantime, let me delete those. V2 deletes, V3 deletes, delete. me send it to myself, and then we'll get it printed. And then while we do that, we'll kind of work on everything else. For some reason, my AnchorMake does not allow me to log in on my desktop. I think it's because it's running off of Windows 10, but I don't see how that would be an issue. Whatever. So in the meantime, let me send it to myself. Cool. Alright, give me one sec. Download. Give me one sec, stream. I'll be right back. Alright, sorry, stream. Had to put some laundry in the dryer. One second. So let's start this print while. Alright, so while that's printing, we'll get to work on the rest of everything else. Alright, so just to go over kind of what we're gonna try to work on. So now that we have the housing set up, I think I might want to make like a little indent right here, or at least a hole, so that way we can run the wiring to our servos. I feel like I can see a problem coming in the future with at least these servos, where they might not be strong enough to move what we want to do. But I did some research, and I wanted to have a planetary gear design on the bottom here, and then with the servo in the center. Now, with the math on that, I do believe it'll still be able to move it even ever so slightly. But in the future, I think I am still going to have to upgrade to stronger servos. I don't know if on the bottom I want a stepper motor. I feel like I'm going to want a stepper motor. Rotates in a series of small and discrete angular steps. That uses position feedback, a linear or rotational position to control its motion and final position. But if it's going in small steps, I feel like that's just going to make the robot jitter a lot. And that's kind of what I don't want. I want it to be smooth. I do want it to be smooth, but I don't know if just a bigger servo motor is gonna be actually, I think this might be what I want. Just a larger servo. But then again, we're also going to have to design a PCB that'll be stronger, or that'll be able to maintain higher power through it. And then I don't know if we're going to go with a battery-like system, or if we're going to have it plugged in, or hardwired, I mean. I don't know, that's the conundrum that I'm kind of facing with all of this, but I feel like once we build it out, then we'll kind of get to see where our mistakes are, and then what we can do to fix them. So okay. All right. So I don't know if I should design the gear system first, or let me see what I have in my notes. And then we'll also have to add, so what I'm thinking is if we're gonna operate off of a planetary gear system, the inside here, wait, can I just get like a regular pointer? The inside here, we're gonna have our teeth, and then we're gonna design the gear system to fit within those teeth, and then in the center is where I hope the servo is gonna be. And then if we have it like that, then we can run the wire. Oh well, I'll have to figure that out. But then, how are we going to? How are we gonna run the power? That's another thing that I'm just figuring out now too. Because if we have a wire running through this slot here, then that means it's going to mess up or come in contact with one of the teeth, unless we have an indent down below to where we'll run the wire. See how thick are these? So 8 millimeters. Alright, let's make all these support structures and everything go. Alright, so we have our lower ring and upper ring. Wait, why did that just upper ring? There you go. Okay. Let's go back in orbit. We'll have to cut something out from there. Let's see if we can get a top angle. We'll have to cut out the spacing there. Okay, let's start by creating a slot that we can use. So this is gonna be 8 millimeters by. Well, all that should matter really is the width. So we'll do like a. Do like a 9 millimeter square. By 15. God damn it. Gosh darn it. Nine by 15. And then what we can do is extrude it. So this is about 3 millimeters in height. So I need this to be a little bit longer. Alright. Nope. Is that raising its height? Yeah, it is. Should I have it take up the width of that? Oh no, but then we gotta remember that we don't want it to come in contact with the teeth at all. So if we're looking at it here, I think what we need to do is we need to rotate this, zoom in, angle. Okay, so right here is where we'll have that. Try to censor it a little bit. And top down view. And so I want it to be, nope. And so right there is where it comes in contact with the wall. And right about there is where we lose it. Alright, so if we make this disappear, then we can enter. All right. So that's approximately how long the wires can run or should run. And then what we can do is we can extrude it downward. Yeah, okay. So enter, and then we can take our lower ring again. Just make sure it's at a good angle. See if we can get a bottom view. Ah, shoot. You know what? Wait, no, how do I... Fuck, how do I, reverse that? There we go. Okay, okay. That's... We can take this face here. Extrude. Get another top-down view. We want it about there. About to this line. We'll put 1, 2, 3, 4, 5. Perfect. So now I believe if I get a side view of that, let's get our lower ring back. No, why aren't you moving? Please move. There we go. Let's get our lower ring back. Center it up. Get a different angle. Oh, music. There we go. And then I think that's good. Now, if I take our shape, hopefully. No, it. God damn it. Nope, that's not doing anything. Or am I gonna have to create the shape differently?
The average person may hear this and think, oh, it's just a more high-tech simulator. But this is an entire league.
Eat my ass, bro. Oh, okay. Okay, hold on. Let me get another top-down view. Let's get the microcontroller body. I feel like I'm gonna mess this up. What should I do? I mean, regardless, that space is gonna be fine. It can fit more. Needs to be raised up just a teensy bit. So let's do that. Rotate. So we're gonna do -1. Nope, that's 10. -1. And that should be. My God, I hate this. Okay, that's a little bit up, yeah. Okay. And then now we'll go over to this way. That's good. Don't combine, good. Now we'll go down. Select our face, extrude, bring back our microcontroller housing. This is going to be going about 12. I think I forgot to cut it. Yes, I did. So select our face again, extrude, cut, microcontroller, 12, maybe 13, maybe 14. What is the issue that I'm facing here? Do I make it thinner and then extrude? Alright, give me 1 sec, I'll be right back.
No matter your passion, every great story begins with a simple idea. In healthcare, it's the dedication to healing. In trade, it's the craftsmanship of creating. In computers, it's the innovation of solving problems. And in culinary arts, it's the joy of crafting extraordinary experiences. Whatever your field, your story is waiting to be written. Start creating it today at YTI Career Institute.
We're doing a complete reno here. Focal Point come in and they got the job done. They didn't take a lot of time. They didn't call me and say, hey, we can't make it till the next date. They were here when they said they were going to be here, and they did what they said they were going to do in the time that they said they were going to do it. My name is Randy Ziegler. I'm from New Cumberland, Pennsylvania, and
All right, we back. Sorry, had to go potty. All right. All right. So I think I kind of know what the issue is here. Let's take our face. Let's extrude it. Let's make it smaller. We'll place it on top, and then we'll put it back on the ring. Extrude it with the micro controller housing, and then that should work out. It should. -1, 2. There we go, that works. Okay. Take this. Put it right back here. Let's get another view of that. I think right there should be fine. Alright, that should work out fine. So this is not cutting out the slit on top here. Let's see what that looks like. Alright, perhaps we raise it a little bit more then. It's just I don't want it to affect the teeth when we put in our gear system, because that's, I don't know how much it's gonna affect it. really shouldn't, as long as there are teeth, right? It's like, even if I cut that out and I still make teeth right there, we can still run the cord underneath here and it won't affect it. And plus, it doesn't have to, I don't know if it's gonna have to be the exact same size. Well, size meaning like, if I'm gonna have to create our gear system with the exact same like width that this inner ring has. So I don't want it to mess it up. Alright, let's just try cutting it now. My controller housing, get out of here. I think now we can just select our face here, extrude, front, down, nope, cut, down, boom. And disappear. Voila, maybe? I mean, that looks like it'll work properly. And again, I can also select that face. So let's see, so if it's gonna go here, I want to create at the center. A 32.4 millimeter, say 32.5 millimeter square. Alright, stream. I'm gonna go for about another 10 to 15 minutes here. I'm gonna get the spacing for the servo about right, and then I'm gonna end the stream. We'll possibly be back live later. I just gotta make some dinner. But we'll see. So in the meantime, let's just make this. So 32.5 and length, and then as far as width goes, at 12, 12.10, just so that way I have enough space there. And then let's extrude this up a little bit. The height of the servo is, not including the gear on top, 28.5. So 28.5. Let's get a top angle. Select, rotate 90. Boom. Take this, move it over. Gotta make sure that this, so we gotta make sure this gear on top here is gonna be exactly centered in our lower ring. Because if it's not, then our gear system won't work properly. Is there a way I can just center it? Sorry, give me 1 second. Alright. If we're looking at wiring, got a top down. This is where the wire is gonna run. So would be like around here. .2. How about 6.25? I feel like that's gonna be center there. Huh, that actually might be it. I'd be real disappointed if it's not. So let's take this. Let's get a side profile. Can't tell if it's hovering or not. Oh yeah, it is a bit off the ground.
Thanks to QuickBooks Business Tax Deduction
Oh, come
Features,
on.
I found $6,000 in tax savings. And
Alright, so now what we can do is we can hide our ring. extrude. Let's bring our ring back. So as far as our depth, we're looking to do... Need this to be tight. 28.2. That's too far. Let's see if that works. Cut. Hmm. Let me see. Okay, I don't think that's gonna work actually. Alright, let's take our part again. Let's raise it up a little bit. And then lower ring down. Take that. Extrude front. 28.5. Our lower ring. Wondering if we make it smaller and then add 28.5, will we be able to see? Wait, what the fuck? Alright, let's try that out. Let's make it smaller and then make it as small as we possibly can. Measure the distance from here to here, about 0.5. It's 28.5. That'd be 29. Make it even smaller. I just gotta make sure that this fits properly. I don't want to have to redo this, especially with the base. The base is gonna be a pretty expensive print if I try to just do it multiple times. So that should be point 0.1. Yeah, 0.1. Okay. So then if we take this face now, we do 28.4, we should be able to get a 28.5 long insert. So 28.4. And then let's bring back our lower ring. Actually, and this should allow our servo to be dead center. I'm gonna have to do a print on this later. Once that one's done, I'll do a print on this. What we'll do is we'll extrude the sides down. Let's get this face handled as well. We'll extrude the sides down, get it printed, and then we'll test out the sizing with the servo, just to make sure it is centered as well. Let's take this, extrude. This really doesn't matter on where it's located. As long as it's semi-centered, we should be good to run the wire. So let's see. We raise it. And then we'll lower it once we do this part of the cutout, but we want to make sure that this is aligned, honestly. I don't want to take the chance on that. So let's extrude. I'm cutting.
This is big, huge, enormous, humongous, gigantic, galactic, gargantuan. Sorry, so excited. Check out these mega must-haves for
Now
the big game. The Hisense
we can take
100
this.
class QD7 series QLED TV is so
Oh,
big.
come on. It's gonna be negative, yeah. So negative 0.1, 0.5. That looks about right, right? That's 12.1. And then we do inspect. Side, that side, that's 9. That should be good. Okay. Alright. Boom. So now we can take our face, we can lower it. $29.5, right? And then you can make that disappear. Get a top-down view. Extrude that. Let's bring our lower ring back in. Let's make sure we cut. And then since that is 0.1 millimeters, we're going to do 28.4. Cut. Nice. I think I might want to make... What am I doing? To cut it down ever so slightly. By I believe it's gonna be 4. Let's do 6, and that's it. So now that that's larger, now we should be able to fit our servo here. And then we can run the wire through there into our microcontroller housing, which is there. Which is there. Let me see if I can actually take that face. Negative 1 point. Cut it down a little bit. So now, if I zoom in here as much as possible. Oh my god, this thing is so annoying to work with. Should be very little gap. And then that should allow us to run our wires through, which is good. Cool. So, I'm going to allow that 3D printer, or that print to finish up. We got our microcontroller housing. We have the insert for the servo. What I want to do is I'm going to end up printing this ring here as soon as that other print's up, and then we're going to test to make sure that the servo actually fits, make sure that we can actually run the wires through it. Let me do a quick little adjustment actually before I go. No, 1. Shit, what the fuck? What did I do? What did I do? Oh, 210. Uh, 2.05 maybe? 0.5 works. Okay. So now I think that should allow me to put teeth on the inside of this ring without having to have a gap. So the rings can be pretty much the width of the inner teeth, if that makes sense. But yeah, so that should allow me to fit the servo in. If the servo is tight or just has some issues fitting, then we'll adjust that later. But I don't think it should have too much of a problem with fitting. Let me see if I can measure out the length between these two sides here. 1 and 2. It's 12.1. It's 12.3. So I think we should do 0.2 on each side. So negative 0.2, and then we'll take this side here, extrude, top, negative 0.2. And then that should allow us to have a little bit more wiggle room to fit the servo on the inside. But other than that, I think that's a perfect placement for it. And we can run those wires through. That'll meet up with the microcontroller housing. Make everything else visible. This we can delete. Hello? No, I fucked it up, dude. I don't get why that would mess it up. This should be good to delete. You don't even need to see that. Yeah, so that should be good there. Let's add everything else. Our upper ring. Okay. So, this is pretty much the basic version of how this is gonna look. Honestly, I don't know how comfortable I am with that being on top. Maybe I'll need to mess around with it a little bit more, make it look a little bit more stylish, but I just feel like that right here is just not it. Maybe I make it a little bit larger. That could work. But then next stream or video that I end up making, we're going to input our planetary gears, input the shaft that it's going to be turning, and then we're going to start on our second axis here, which is essentially elevating the forearm